So this section we're going to be talking about, and actually I'm going to combine both of these sections because these two sections are very short. So 11.7 and 11.8, we're going to be talking about the counting principle and permutation, and we're also talking about combination in section point 8. So let's start off with the first part, where first I want to explain this here is called factorial. And all factorial means is when you have, let me go to my other screen so I can show you. So we have 9 factorial. All this means is we're taking 9 and times it by 8, 7, 6, 5, 4, 3, 2, 1. And multiply all those together and it gives you the same answer of what it's supposed to be equal to. So this is basically what it means. You're just going backwards and multiplying all the numbers backwards. So to find the factorial button on the calculator, you're going to hit math, and then you're going to scroll over to where it says probability at the top, and then go down to number 4. So for practice, if you do n factorial, that equals 24. Same thing as saying 4 times 3 times 2 times 1, which still equals 24. Same thing with 7, just going backwards. Here's what it's equal to. So this is what factorial means when we look at these problems. So in this first example, how many different ways can the letters Cincinnati be arranged? So with arrange, we're still going to be going back to that counting principle that we discussed earlier in this section. So let's talk about it. The first part of it, how many letters do you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 factorial on top. So this is where we have the actual number of what we're discussing, and then this is the drop off as far as each of the different parts inside of the problem. So let's go back. So for 3, where did the 3 come from? So if we look inside the letter and we look at the eyes, how many eyes do we see? 1, 2, 3. So we have 3 factorial. Here's this 3. This came from the ends. 1, 2, 3. The 2 come from the C's. 1, 2. And notice we didn't put the other letters because the other letters only came once. So the other letter in this problem will be A and T. So if we can put it down here, but it's not going to really matter because 1 factorial is still 1, and then 1 factorial for the T is still 1 also. So 1 multiplied to all this, it really doesn't matter. So that's why we're not putting the 1s in it. So here, this is how you do it by hand. I'm going to actually show you how to do it in the calculator, but by hand, they kind of broke it down where we take 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then for the 3, 3, 2, 1, this 3, 3, 2, 1, and then this 2, 2, and 1. So looking here, find the ones that match. 3, 2, 1, 3, 2, 1, that cancels with this one. 3 times 2 gives us 6, so these 2 cancel. And then if I reduce it, 8 over 2 reduces to 4. So like I said, if you're doing this by hand, everything on the bottom cancels out, and it just left you with the 10 times 9 times 4, 7, 5, and 4 over here and multiply to give you here. So we can do this in a calculator. Just remember, put both top and bottom in parentheses once you do it, and you still should get the same number here. So let's go to our calculator. We're going to do parentheses 10 factorial. So hit math again, over to probability down to number 4. Divided by, and these you don't have to put each one in parentheses, just the whole thing. 3 factorial. Three factorial again. And this time 2 factorial. Close parentheses equals, and this is how we get the same number from the slides. Let's move to the second one. So permutation formula. So we're looking at permutation formula. Here's the formula for it. For once again, I'm going to actually show you how to put this in the calculator, so there will be no need to work it out by hand. I'll have the by hand down here as far as working out, but you're more than welcome to just put this in your calculator and use the P formula in our calculator. So looking at this one here, the N represents the number, the actual number of objects there is, and the R will represent the number of possibilities it could be. So if we're looking at here, there'll be 9 as far as the totals. Let's go back and count. Among 9 people forming in the astronaut club, we put 9 for N, and how many different kind of possibilities it can be. You either can be a president, vice president, or secretary. So this is where the 3 came from here. So how many different ways we can arrange officers are possible. So when we see that word possible, this is where we either going to use P or C for problems. So we do this 9 into here, we get 504. So here's the steps on the calculator. We hit 9, math, again go over to probability, and then this time we're going to hit number 2, and then number 3. This is actually for the old style calculator. Let me show you the new style for those that has the upgrade advanced calculator. I think with those you can just actually just put in, let's go over and get it, and then this will be number 2. So here they actually have the little squares provided for you, so you can actually just put in the numbers here, 9 and 3. But the older ones, you actually have to do the steps that I showed in the slides. And we get the 504. So the biggest difference between permutation and combination, the one we're going to kind of go through for, is with permutation, order matters. So anytime you read a word problem and the order of the, as far as the arrangement and possibilities has a significant matter to it or matters deeply, then we're going to be using P for permutation. Now combination in section 8, this is where order really does not, it's not really important. And this is where we use C. So here's a formula again if you'd like to do it by hand. Again, I'm going to show you how to where to get the C in your calculator. So looking at this problem in your American history class, you are assigned to read 3 books from a list of 8. How many ways can we select 3 books from 8? So here, does the order matter in this one? Do we have to read it in a certain order or the number of books on here? No, it does not matter. It doesn't tell you what you had to read first. Well, however, when we're talking about this problem, we have to vote on the president, vice president, and secretary. So order does matter in this one here. We have a certain order that we have to do it in, and we have different categories that we need to put it in. So order matters. This is where we put P. When order does not matter, this is where we put C. And number 3 represents C when we go get it in our calculator. So here we're going to put 8, go get this C, and then number 3, for those of you that have the high-tech one, you can just actually go grab it and place in 8 and 3 and get 56 for this particular one. So once again, order does not matter in this one here. So another way to look at it also, as far as so you won't get the numbers confused, in pretty much all these problems, the bigger number goes first as far as the number we have. So you should have the number that we're talking about in should always be the bigger number than the different possibilities. So when you put this in your calculator, make sure this number is always a bit larger than this number, because then it'll give you an error in your calculator if you have it backwards. So to kind of give you another example of which one it should be when we're working these problems, we have a group of 5 friends that wants to form a club. So how many different ways can the president and treasurer be selected? And here it looks like it's very important that we have the order in line. So remember, order, when it's very important, we're going to use in permutation, which is P. Oops. So here, so order selected is important. So this one here, we're going to be using permutation. So we'll be using the P. This one here, which one should we use? Well, if Jan has 10 photos, and she chooses to hang them on the wall, there's not really a specific order that's going to be an importance. So combination is probably the one we're going to go with in this one. So again, the bigger number 10, because that's the total number. With 6, put in a calculator, we get 210. For this one here, there might be 2 parts that you have to do for the problem, but just to kind of go run through it, a dinner consists of 3 items from column A, selecting 4 items from column B, and 3 items from column C. If columns A has 5, this column B has 7, and this column C has 6, how many different combinations are going to be possible? So here, 5 and 3, remember, for A, we have 5, and with 3 items for A. So big number on first, and then second number. For B, we have 4 out of 7, so we have 7 and 4. And then for C, we have 3 out of 6, 6 and 3. So here's the 6, here's the 3 for C, and 7 and 4 for B. So we're going to go back and do the counting principle since we have multiple combinations that we have to do. We get our answer, times by this answer, times by this answer, multiply them all together, and we get 7,000. So here are a few examples from our MathClass Plus. Looking at this one here, it says how many different 3-course meals can be ordered, not in range or possibility, but ordered. So this is where we're going to go back to what we talked about as far as the counting principle, when we just multiply all the numbers together. 4 times 7 times 5. We multiply those together, all of those parts together. 4 times 7 times 5, and gives us 140. So the key wording here is the order, because the other ones would deal with possibilities or arrangement. So here we have that possibility. So we're going to be using P, or we're going to be using C, because now we got to go back and see what is the most important one. It looks like here, since we're arranging flowers to be cut and plans to use 6 of them, how many different selections of flowers can be? I think C is going to be here because it's not really in an order that matters. So because order does not matter for this one, we're not using P, we're going to be using C for this one. So 22, C, and then 6. So calculator. So we can, for here, the high-tech ones, you can just go get it. And then place them in, 22 and 6. And we get 74,613 for that possible answer for flowers. So that is section 11.7 and 11.8. And if you have any questions, let me know. That concludes chapter 11. So once you finish reviewing and doing all my math problems for each section, you'll be ready to review and start your tests.